Fourth question, it's a question on algebra functions. Let f and g be defined on R to R respectively by f of x equal to gx plus 1 and g of x equal to 2x minus 3. Find f plus g, f minus g and fg. Okay, so we have seen this in algebra functions. Two functions are defined, f of x which is equal to x plus 1 and g of x which is defined as 2x minus 3. Alright, and we have to find f plus g of x, which would be simply mean f of x plus g of x, which would mean adding those two functions. Let's just do that. X plus 1 plus 2x minus 3, which would equal to 3x minus 2, right? And the second sub question, f minus g of x, which would be f of x minus g of x should equal to x plus 1 minus, we have to be very careful with the brackets, minus g of x, so minus of the whole 2x minus 3, not just 2x minus 3 gets the minus. So opening this bracket we get 4 minus x, right? If we open the bracket, this becomes positive 3 plus 1 4, and opening this we get minus 2x plus x minus x, so 4 minus x. And the last question, f dot g of x, which would be pointwise multiplication of functions f of x times g of x, which is equal to x plus 1 times 2x minus 3. We get a quadratic equation, 2x square minus 3x plus 2x minus 3, which would equal to 2x square minus x minus 3. So that was that. It was a simple question on algebra of functions which we have learned in part 2. Question number 5. Let a equal to set 9, 10, 11, 12, 13 and let f of function be defined from a to n, where n is natural numbers, and be defined by f of n equal to highest prime factor of n. Find the range of f. Okay, so we have a function which is defined from R set A to natural numbers. So A is our domain and natural numbers is our codomain, and we are given this function f of n is such that it equals highest prime factor of n. So if we give n as input, it will give output as the highest prime factor of n. And we have our set A, which is equal to 9, 10, 11, 12, 13. We have to find the range of f. This is quite a simple problem. We just put each number from A into the function f, and then we get the output, and then we write all the outputs in a set, and that will be a range, right? Because our codomain is A, no, our domain is A. So if we give A to our function, we get all the outputs. If we club all the outputs into a set, that is our range, because set of outputs is our range. Set of all possible outputs is our range. So we put the set of all possible inputs into this function, and we get the set of all possible outputs, and that would be our answer as a range. So first let's put n, 9, f of 9 would be, so we have factors of 9. What are the factors of 9? 1, 3 and 9. So it's not much. So what's the highest prime factor of 9? We have 1 is not a prime factor. 3 is a prime factor, 9 is not a prime factor. So the highest prime factor of 9 would be 3. F of 10. The factors of 10 would be 1, 2, 5 and 10. And the highest prime factor of 10 would be 5. Yes, because 10 is not a prime factor, highest prime factor would be 5. F of 11 next. 11 is a prime factor, prime number, and its prime factors are 1 and 11. So the answer would be the number itself, 11. F of 12 12 would have factors 1, 2, 3, 4, 6 and 12. So its highest prime factor would be 3, because 4 is not a prime factor, 6 is not a prime factor, and 12 is definitely not a prime factor. So 3 would be its highest prime factor. And last, f of 12, f of 13. 13 is a prime number, so its highest prime factor would be the number itself, 13. So we have all the possible outputs. We can club that as a range. Range would equal to 3, 5, 11. We have another 3, but we don't do repetition in sets, so we can avoid that, and 13. So this would be our answer. We can do the 6th question here itself because we have a little space. I'll put this okay. 6th question. Find the domain and range of f of x which is equal to root of 9 minus x square. Okay. So we have our function f of x which is equal to root of 9 minus x square. Okay. So finding domain means finding all acceptable values of x. Right? So we can do that by looking at this logically. We know we cannot have negative numbers inside a root because that will result in complex numbers or imaginary numbers. We want real numbers for our answer. So what do we need to do? We have to place a constraint. A constraint is something that cannot happen. So like 9 minus x square, we need that to be positive. So we can give the constraint 9 minus x square should be greater than or equal to 0, which would mean it would be positive. We have to solve this inequality and get all the possible values of x. Then we get our domain. So let's do that. 9, we take minus x square to that side, we get x square. We take square root on both sides, we get x, and plus or minus 3. Don't forget that when we are taking square root, we can have plus or minus 3. So if we apply 3 plus 3 first, the sign doesn't change, it remains like that. So plus 3 greater than or equal to x. But if we apply minus on one side, we have to flip the sign. Which is really important in inequality is that if you apply minus somewhere, you have to flip the sign always. So if we apply minus, we have to flip the side. So it be x is greater than minus 3, but x is less than 3. So the domain would be included minus 3 to 3 square brackets because both of these numbers are included. So this would be our domain from minus 3 to 3. So x can have all acceptable values from minus 3 to 3. Now we need the range. What is range? Range is the set of all possible outputs of this function. So if we give minus 3 to this function, let's see what happens. If we give minus 3 to this function, we get root of 9 minus 3 square is 9, which is equal to 0. If we put 3, which is the highest in this domain, we get 9 minus 3 square 9, which is equal to 0 again. So if we face a situation like this, let's check the middle number. What would be the middle number? Negative 3, negative 2, negative 1, 0. 0 would be the middlemost number. So if you put 0 here, we can get 9 minus 0 square is 0, which means root of 9, which is 3. So 3, it appears that 3 would be our highest number so far. And since if we put something to the right of 3 is from something to the right of 0, which would be 1. If we put 1 here, it will be root of 9 minus 1, which is root 8, which is 2 root 2, which is definitely not higher than 3. It would be approximately 2.828. So we don't need that. We need the highest number. So range can only go from lowest to highest. So range here, which means range would be from the lowest value 0. 0 is our lowest value, and the highest value we have is when x is equal to 0, and that's 3. So this would be a range 0 to 3, and our domain would be negative 3 to 3.